Okay, hello everybody. So moving on with the next topic. In this particular video, we will study about the types of schedules. Okay, so that you will be seeing. Okay, so schedule is not like a transaction, but it is referred to as a collection of transactions. Okay, so I'll get to it. Okay, so first thing, we'll study about types of schedule. So you will find it in any book you can take. So I'm just writing simple definitions so that you can just simply remember it. So what is a schedule? A schedule represent the order in which the operations of transactions are executed. Okay. So how does it work? I'll just tell you. Okay. So suppose this is a schedule 1. In this schedule, suppose there I'll take one transaction. In transaction T1 there are two operations, A1 A2. Transaction T2 there are two operations, suppose B1 B2. Okay, so a schedule represent the order in which the operations of transaction. So this is transaction, this is their operations. Okay, A1 and A2 operations, B1 and B2 is also a set of operations. Okay, so how they are executed, how they are maintained in a order, it will be referred to as a schedule. Okay, so suppose this is schedule 1 S1. Now how this schedule 1 is arranged, T1 T2. Suppose I am arranging it as A1 A2. After that we have executed B1 B2. Okay, schedule S2 will be, suppose transaction T2 is executed completely first, and then we move on to transaction T1. Okay, now similarly there may be other ways to arrange the transaction. There may be other ways. Okay, so suppose there is another way, S3, and there is T1 and then T2, then execute one operation of T1, then execute another operation of T2, execute another operation of T2 T1, and execute another operation of T2. Okay, similarly you can just change here also. First execute this one, then execute this one, then execute this one, then execute this one. Okay, so the order, so this can be referred to as schedule 4. Okay, similarly you can take another combinations as well, like I'm taking S5 as there is transaction T1, transaction T2, so I'm taking A1 and I'm executing B1 and B2, and then I'm executing A2, something like that. And there will be S6, T1 and T2. I can do a similar thing here, B1, A1, A2, and then B2. So this can be also another schedule. Okay, so this is how you can arrange a different transaction. Okay, so just take a look at the first two. When transaction T1 is over, you are going towards transaction T2. Similarly, in S2, when the transaction T2 is over, you are going towards transaction T1. Okay, so these are referred to as S1 and S2 are serial schedule. Serial means that you are executing everything serially. When one executes completely, then you move on to another transaction. Okay, so here if you are seeing here, S3 is interleaved in between, S4 is also interleaved in between, S5 is also interleaved in between, meaning that transaction T1 is not completed and you are going towards transaction T2. Similarly, this happens here. Okay, so you can say S3, S4, S5, and S6 are non-serial schedule. Okay, sorry. Okay, so you have to make sure that it should follow a particular order. It should not be like that you're writing the transaction like T1, then T2, and you're writing A2 first, and then you're writing B1, B2 here, and then you're writing A1. Okay, you cannot change the order of the operations inside a transaction. Okay, so this is not a schedule. S6 is not a schedule. Why? Because the transaction order is not maintained. You have to maintain the transaction order as well, individual transaction order. Okay, so now uh, you can find the number of schedules here, how many number of schedules can be there if there are some x and y amount of operations are given in a transaction. Okay, suppose T1 has n operations, T2 has m operations. Okay, so the question is how many ways schedules can be formed. How many combinations of schedule can be formed? You can think of it like that. Okay, so it is n plus m whole factorial divided by n factorial followed by m factorial. Okay, so in our case, if you see the previous question here, so there are two transactions. It has two operations. T1 has two operations and T2 also has two operations. Okay, so if I write here n, the value of n is 2 and the value of m is also 2. So I write 2 plus 2 over 2 factorial followed by 2 factorial. Okay. Okay, so 2 plus 2 is 4 factorial over 2 factorial. 2 factorial. So you can solve it. 4, 3, 2, 1, 2, 1, 2, 1. So it is simple. 2 2 is the 4. So 3 2 is the 6. So there are total 6 schedules. There are total 6 schedules, out of which 2 schedules are serial. Okay, 4 schedules are non-serial. Okay, so you see, check here. There are total 6 combination schedule: S1, S2, S3, S4, S5, and S6. Okay, so there are 6 schedules that are being formed, and 2 schedules will always be serial. Okay, so that it depends upon the number of transaction. Okay, so if there are 3 transaction, so it may be 3 factorial serial schedules that can be there. So I'll tell you, don't worry about it. Okay. Okay, so now I'll write the whole formula. Okay, it will be easier for me as well. Suppose you have transaction T1, T2, T3, which have operation something like A1 operation here, A2 operation here, A3 operations here, and then there is transaction Tn which have AM operation, something like that. Okay, so how many schedules are possible here? It is number of operations A1 plus A2 plus A3 up to AM. You just do the factorial part here, and then you do the individual factorial. We already know that. I think this is done in the previous one, up to AM factorial. Okay, so now suppose this is total number of schedule. Okay, so these are total schedules that you will find, total schedules that are being possible. So I'm considering this value as A. Okay, considering this value as A. So the serial schedules that are being possible. Okay, serial schedule that are being possible, it's totally dependent upon the number of transactions. Okay, so here the number of transactions are 1 2 3 4 up to m transactions are there. Okay, so I'll say that if there are m transaction or n transaction. Okay, so I'll executing, I'm saying that there are m transaction, total m transactions are there. Okay, just let me check. There are, sorry, n transaction with m operations. Okay, so I'll say n factorial, there will be your serial schedule. Okay, check here in the previous example. How many transactions are there? Two transactions are there. Okay, check one or two. What is 2 factorial? 2 factorial is 2. So that is why out of 6 there are 2 serial schedule and the remaining are non-serial. Okay, so I'm naming this as there are b number of schedules that you are getting from it. Okay, so now what are the non-serial schedule that are being possible? So non-serial schedule will be, you just minus total number of schedule, from total number of schedule you just minus serial schedule, you will get the non-serial schedules. Okay, so it's as simple as that. So just if there is more confusion, I'll just give you an example here. It will be more clearer if I give you an example here. Okay, so suppose there are 3 transactions, T1, T2, T3, and the respective operations here are given are 2, 3, and 4. Okay, so I have to find all the things. Okay, so what are the things here? 2 plus 3, if you want to find the total number of transaction, 2 plus 3 plus 4 factorial, 2 factorial followed by 3 factorial followed by 4 factorial. I think it is 9 factorial over 2 factorial, 3 factorial, 4 factorial. Okay, so solve it. I think it is 1260. Okay, so 1260 total number of schedules that are possible. Okay, so out of which how many serial schedules? So total number of transactions are 3. So serial schedules are 3 factorial. So it will be 6 serial schedules. Okay, so non-serial schedules will be 1260 minus 6. It will be 1254. Okay, you calculate it out. So just a simple example. Okay, okay, so this is the whole concept of the schedule part. Okay, so moving on forward, what are the types of schedule that you can find? So first one we have already seen. I think I've given you plenty of example here, is a serial schedule. First example will be serial schedule. Okay, so serial schedule is that if there is no interleaving in between the transactions. Okay, so suppose there is transaction T1, transaction T2, suppose there are 3 transactions and they are reading the value of A, they are adding the value to be 100, writing the value. It is completely over now. Now you are reading the value of A again, you are subtracting something out of it and you're writing the value of A again it is completely over. Then transaction T3 works, this reading the value of A again, you are adding again 50 rupees and you are writing the value of A. Okay, so if you're doing that, this is referred to as your serial transaction. Okay, similarly this can also happen in any way. You can execute T2 1 first and then you can execute T1 and then you can execute T3. Similarly, you can already know there are 6 ways to arrange the serial schedules. Serial schedule is when there is no interleaving in between. Okay, so if there is interleaving, that before completing the whole transaction you are moving on to another transaction, that will not be referred to as a serial schedule. Okay, just keep that in mind. Okay, okay, so we are very much interested because serial schedule are a standard schedule. Standard means that whenever you are executing any transaction, when you are doing it serially, means that when first transaction is completing, then only you are transferring the control uh, for another transaction. It means that there will never be an issue. Why? Because there is no concurrency here. Okay, because when T1 is executing, nothing is executed here, you can see. When T2 is executing, nothing is executed. When T3 is executing, nothing is executed. Okay, so it is not very efficient, but it will always be correct. Okay, so we want our non-serial transaction to be the to be like serial transaction. What do I mean by this is that what will be the output of the serial transaction should be the output of a non-serial transaction. Okay, so again, another schedule will be your non-serial schedule. I think we have already seen an example. I'll just show you again. Non-serial schedule. Okay, suppose again transfer 50 rupees. Now you're interleaving this transaction. You are again reading the value of A, nothing, writing the value, and you're adding 100 rupees to it. And you're writing the value of A, and then you're writing the value of B. Okay. So again, if you're seeing here, right conflict is there. This is a lost update problem, but again, it is not a serial schedule. Okay, because there is interleaving. You're leaving the transaction in between to move to another transaction. So it is referred to as a non-serial schedule because it is not following the properties of a serial schedule. Okay, so now moving on to another part is a complete schedule. Okay, so I'll only try to give you an example. It will be easier for you to understand if I just presented you with an example. Okay, so complete schedule is if the last operation of each transaction is either commit or abort. Is commit or abort. Okay, so if it is either of the two, then I can assume that this particular schedule is complete. Okay, so I'll give you an example here. Transaction T1, transaction T2. You can take the same example. Suppose transaction T1, we are deducting 100 rupees. Write the value and you're writing commit here. Okay, now the transaction T1 is completed. Now you're writing another value. I can interleave the transaction in between as well. Suppose by reading the value, I just interleaved 2A here. Just wait a second. Oh, sorry. Here A, and then you are adding the value, writing the value, and then there is some failure here. Suppose this is abort. Okay, so when you're writing abort, everything will be rolled back. Okay, so in this transaction, the last statement is either commit or abort. So I can consider this is a complete schedule. Okay, so because there is a commit, the changes are permanent. Because there is a abort, everything will be rolled back. Okay, so this is referred to as a complete schedule. Okay, so now the most important schedule is there, that is referred to as recoverable schedule. So understand this schedule very carefully because it poses a lot of confusion. Okay, so I'm writing example here, just try to understand it. It's again very close to the example that we have already given you, that when you're reading from uncommitted data, if you remember, or dirty read problem. Okay, so recoverable schedule is also it's based on commit or abort also. Okay, so I'll present you an example. It's very easy. The example is again very similar. You're transferring 100 rupees. Adding 4%. Seeing here, T2 is submitting the sheet to the invigilator. Now, when it tries to update here, the transaction fails. So I'm taking the same example here. Abort, everything is rolled back. Okay, check here. Now, this is an example of a non-recoverable schedule. Okay, so I want to give you an example of recoverable and non-recoverable. So I'm first giving you an example of non-recoverable schedule. Now, why is that? Because you started with the value 100, changes to 50, changes to 50, read the value of 50, made changes to it, and it is committed. Now, the actual value of 100 is now changed to 50, and now it is changed to 52. But when the rollback happens, it is again changed to 100. Okay, so this is a problem here. Because of this rollback, because I have already committed T2, T2 has already committed before T1, so I may not be able to roll back. Because if I have committed first, the changes are permanent. I cannot change the value to be 100. So if it is aborted, it will not be aborted because I already a commit is being made. So I cannot recover this transaction T2. So that is why this is referred to as a non-recoverable schedule. Now why this happen is because we are reading from uncommitted data. Uncommitted data. Okay, so if I give you a simple definition here that you can find it on any book, but this is very important to understand the transaction definition here. If Ti is writing, I'm just writing this definition so you understand it clearly, and Tj is reading from Ti, and Tj commits before, Tj commits before Ti, it is not recoverable. If it commits after Ti, then it is recoverable. It's a very simple definition. Okay, so it means that if T2 transaction have delayed the commit, if it had delayed the commit here, okay, so if it had delayed the commit here, then when the transaction aborted here, it can also abort or it can also roll back. It has the option. But when it put a commit here, now it cannot be rolled back because the changes that are made are permanent. Okay, so if I change the transaction, if I want this transaction to be recoverable, what I have to do is I'm changing some aspects of its transaction. T1, T2 are A, same transaction, A equal to A plus 50 W of A, and then we're changing towards something same transaction. Okay, so we are here just delaying the commit part. Okay, so here the commit operation lies, and now I'm writing the commit of this after this. So it means that I'm waiting for A to submit its sheet, only then I will submit my sheet to the invigilator. Okay, so what it means is that if T2 is aborted before the commit, then this schedule can be recoverable. So you can also roll back. This can happen. But if there is a commit here, you cannot roll back and everything will be a problem here. Okay. So now keep that in mind that recoverable schedules are needed because we want everything to be recoverable. Okay. So because of this recoverable schedule, there might be a problem that is referred to as cascading aborts. Okay, So that can occur. Suppose I'll give you an example of a cascading abort problem that happens due to recoverable schedules. Okay, so cascading aborts happen due to recoverable schedule here. So now suppose there are three transactions T1, T2, T3, and then there is a read operation. Suppose some operation is there. Okay, so now I'm waiting for commit operation of this, then I will commit, and then I will commit. Suppose there is a failure, then it will also roll back, it will also roll back, and you're seeing here this is a cascading abort problem. Okay, because of this particular abort, T2 and T3 will be aborted. So this is a lot of a time wastage here. Okay, so we are wasting a lot of time because we are reading from uncommitted data. Okay, so how to save this time is that you wait for commit only, then you read the transaction. This can be another a good alternative to avoid this cascading abort problem. Okay, so this is also referred to as sometimes cascading abort or cascading rollback. Okay, keep that in mind. You can avoid it if you only read from the committed data. This can never happen. Okay, so we never want cascading rollback. We want cascadeless transaction. Okay, cascadeless transaction. Keep that in mind. Okay, so now with this we are moving towards our next schedule, that is cascadeless schedule. So I'll give you a definition here because it's very important to understand here, because there is very minute differences between the recoverable and cascadeless schedule. Okay, so that is why I'm writing the definition here. Okay, so the definition of this one is a cascadeless schedule is one where each pair of transaction Ti and Tj, again talking about Ti and Tj, such that Tj, this just read it very clearly, Tj reads the data item that is written by Ti. Okay, then the commit operation, it is all about commit here. Commit operation of Ti should appear before the read operation of Tj. It's very easy to understand. Okay, so it is only talking about when Tj reads the data item from another transaction Ti. So it only reads the data item if there is a commit here. So it is, I think it's more stricter than the previous one. Okay, so previously we are reading that part, but due to this that we are reading from the uncommitted data, we are placing our commit after that transaction. So due to this we are facing with cascading aborts. So what we have decided, we will only read from that transaction where commit operation is already placed. Okay, so it means that it says that transaction T1, it's very, the definition is very close here. I'll want to say very stress upon this word reads. Okay, so I'll give you another example here. Just look at this example. Read a, write a, then commit. Only then I will read here. Read a, then write a, and then commit. Only then I will read from this transaction. Okay, so if I am reading from the committed data, there will never be a cascading abort because the changes are permanent. Now read this particular thing that says TJ reads the data item that is written by TI, then the commit operation of TI should appear before. So it is saying that TJ will only read from TI if there is a commit operation. Okay, but is not talking about anything about the write part. Okay, so if I say, is this a cascadeless transaction? Yes, it's a cascadeless transaction because it satisfies the definition here. Because TJ here, T2 is not reading anything; it is directly writing it. Okay. Hi, however, this is a write-write conflict, but still, it lies in the cascadeless schedule part. Okay. So cascadeless, keep that in mind, that stressing on this part here, that read part, but they are not talking about the write part. Okay, so it means that if you write this particular thing, it will also come under the cascadeless schedule. Okay, so now keep that in mind, every cascadeless schedule is recoverable. Okay, every cascadeless schedule is recoverable. Okay, because if you're seeing here, what we are doing in recoverable is that we are placing the commit. Suppose there are two transactions T1 and T2, and I'm reading T2 is reading from T1. So T2 commit will be placed after the commit of T1. Okay, so it is recoverable because if there is anything happens, there will be a cascading rollback from both sides. But cascadeless ensures that there will never be a cascading rollback. Why? Because we are only reading from a committed transaction. If the transaction is committed, there can never be a rollback. Okay, so there can never be a failure because the transaction is complete. Okay, so it means that it also is recoverable, but it is much more stricter than the recoverable schedule. So that is why it comes under cascadeless schedule. Okay, so you can think of it like that. Okay, so now another very stricter form is a strict schedule. Okay, so these three are very confusing, but if you follow what I'm telling you, you will understand everything. Okay, so now what is it takes out the loophole here. Okay, so what it means is that in the previous we can do what we can do is we can write without any reading. We can write in a transaction T2 on the same data item that will comes under cascadeless. So we are going a step further here. Okay, so we cannot even write now. So what it means is that a schedule is a strict schedule if a value written by a transaction cannot be read. Now this is very important, or overwritten. Now the written part is also here. Read part was already there in the previous one. Overwritten by other transaction until the transaction either commits or abort. So what it means is that, I'll give you an example. So T1 followed by T2, then read of A, write of A, then you do a commit, and then you can write the value of A here. Okay. Previously, in the cascadeless, you can write the value of A before the commit, but now this is not possible. Strict schedule make that particular thing also stricter. Now you cannot also write here. Okay, so previously in cascadeless this was possible. So what was possible in cascadeless? Okay, so this is a cascadeless schedule but not a strict schedule. Okay, so R1 W1 and it is writing the value of A and it is commit. Okay, so this is cascadeless, it is not strict. Okay, so now this particular thing is a strict schedule. Okay, so you can say that every strict schedule is also a cascadeless schedule. Okay, so this satisfies the condition. Okay, so now if you just want to see that what is the actual difference between the recoverable and strict part, so just in simple terms you can think of it that if there are two transactions, if the commit is placed, then you place the commit because you're reading from T1, you place the commit after that. So this is simply, you can call it as a recoverable transaction. Okay, so in cascadeless transaction, in cascadeless one, you can say that uh, I can place after commit I will read. Okay, after commit I will read. Okay, but in stricter one you can say that after commit I can write or read. Okay, so it's also contains the read part. Okay, so this is the main differences between the three schedule. Keep that in mind. Every schedule is cascadeless and every cascadeless is recoverable. Okay, so if a schedule is strict, it is automatically a cascadeless schedule, as well it is recoverable schedule. Okay, now these are your main particular schedules that you have to keep in mind. Okay, so now we will move on towards our next part, that is serializable schedule. Okay, it's very important. So we'll see this particular schedule in the next one. Okay, thank you for listening and I'll see you in the next one. Okay, bye.